Hey guys, if you're available today when you want to do this Enzyme Lab at 3 o'clock, I'm going to be able to do it live on that Google Meet link. So if you'd rather do that there, that's great. But if you don't get a chance, then hopefully you can walk yourself through this and stop the video right now if you need to, and then go work on your Google Doc or however you need to do this. But this lab is all about enzymes. So in this lab, we are going to use 3 different types of liver. We have raw liver, wonderful raw liver. We also have liver that I sat overnight in acetic acid, which is vinegar. So, and then we have liver that we put in the microwave for about a minute. So they're all pieces of liver, and liver has an enzyme called catalase, and that is mainly what we're going to be experimenting with in this lab. But we have catalase in the liver that we have treated differently. So in your lab, I'm actually going to jump ahead. You should have this Google Doc somewhere on this assignment that you can access and get to, and I am going to jump to the second page where it has a place for you to list parts of this experiment. Your variables in this experiment are, the variable, remember, a good experiment only has one, and in this experiment, your variable, your independent variable, the one thing that you do differently is that we have different types of liver, or we have different materials. So in my Google Doc, hopefully I would write my independent variable as that, the different types of liver. My control group, what I'm trying to be normal is how liver really is, and that would be my raw liver. So on your lab sheet or the Google Doc, make sure you write that raw liver is your control group. Now, dependent variable, a good way to remember dependent variable is that it depends on what you do to it. It'll change, but it depends on what you did to it. So we have raw liver, we have liver soaked in vinegar, and we have liver that we zapped in the microwave for 1 minute. So what's going to change? Well, when we give it hydrogen peroxide, a couple of things may change. We may have a change in temperature, and so on your Google Doc, that's your dependent, that's one of them, a change of temperature. Or we may also have a change in the amount of gas or bubbles. So I hope that you have filled in this part on your Google Doc. If not, stop this video for a second and go ahead and fill it in. Also, in that same section, you need to list the constants. A constant is everything that you keep the same. I tried to cut the liver to be the exact same size. We are going to give the liver, each one of them, we are going to give hydrogen peroxide, and we're going to give them 10 milliliters. So we're giving them the same amount. So it would be, the constants would be the same amount of hydrogen peroxide. Hydrogen peroxide is H2O2, for if you need that formula. And we have the same size piece of liver. That makes up a good experiment. We have our independent variable. One thing we're doing differently, we treated the liver differently, or your teacher did ahead of time. Your dependent variable will change depending on the different types of liver, and it will also be something that we measure. We're going to measure the temperature, and we're going to measure the amount of bubbles. Our constants are the things that we keep the same, whereas the same amount of hydrogen peroxide we will give each one, and we started with the same size sample of liver. Okay, so in this lab, basically we're going to take the liver. I've got my test tubes right here. Let me move back so you can see it better there. So we're going to I'm going to put my raw piece of liver in one. Here's my raw piece of liver. Yum, yum, right? I may have to jam it down there a tiny bit. Come on, liver, go. Okay, and in the second one, I'm going to put my cooked piece of liver. This one's slowly sliding to the bottom. And then in my third one, I soaked this wonderful piece of liver overnight in acetic acid, which is actually vinegar. So here is our acetic acid piece right there, and it's synced to the bottom. So we have our control group, the raw, we have our cooked liver, and we have our liver soaked in acid. Now, here's the thing about liver. If I turn to the front of my lab sheet, liver has an enzyme called catalase in it, and catalase will react with hydrogen peroxide. Remember, an enzyme is very specific to a substrate, so it will only react with hydrogen peroxide. Now, the thing about enzymes, if you watched that Nearpod the other day, enzymes are since they're specific to a substrate, this one in this case is specific to hydrogen peroxide, it fits to that substrate like a key would if you put it in a lock. And now there are a few things that can mess with enzymes. If the temperature changes, or we change the pH, or something happens to the fit of that key, it would be like taking a key to go to a building and trying to stick it in that lock, and it's not going to work anymore if it's not the right key and it's been altered some way. So we shall see if that's the case, because we have altered our liver, and that's where the enzyme is. We have altered it by cooking it. We have altered our liver by keeping it in a vinegar. So how are we going to know if something changes? Turn to the very bottom of your Google Doc, and the last question basically gave you the chemical reaction that's going to happen in this lab. It said that we are starting with H2O2, that's hydrogen peroxide, which is a liquid, and from that we will have a reaction. We will have water, and if you watch the pre-lab video, we know we are going to have oxygen gas. Oxygen gas is O2. Now, this is a little bit of review from your 8th grade year, or if you had IPC last year in 9th grade. Here's the thing about this equation right here. It is not what we call balanced. So you need to make sure that you balance that equation in your lab sheet. If you remember how to balance, when you were in 8th grade, we would often do what we call wrap. Over here would go the number of atoms on the reactant side. Over here would go the number of atoms on the product side. In the middle, you would put the elements that are found. And in this case, we have hydrogen and oxygen. On the reactant side, which is the side prior to the experiment, which is hydrogen peroxide, we have 2 hydrogens and 2 oxygens. On the product side over here, if I count my hydrogens, there are 2, which is good because those 2 are equal, but something's not going to add up right, because when I start adding the oxygens, O2 is a gas and O2 has 2 oxygens. Water has 1, so it has 3. So I want you to try and balance that before you turn in this Google Doc. Right now it's not okay. You're going to need some coefficients in front of hydrogen peroxide and in front of water to balance this out. If you have trouble with RAP, let me know. But our main purpose, and my main purpose, is to actually show you this lab. So without further ado, to the front of your side, your instructions will be, we are going to take the temperature of each material before we even start the lab. So I'm going to stick my thermometer into my raw liver. I'm going to let it sit, and I'm going to time it for probably about 20 seconds. So I'll count in my head 20 seconds, and while I wait for it, just to remind you guys, if you were in 8th grade, we knew chemical reactions happened because there were certain clues. City girls love their smartphones, or city guys love their smartphones, is what I often would teach my 8th graders when I had 8th grade. what does that mean? C stands for color, a color change. G, a gas like bubbles. City girls love. L, a light might be emitted. City girls love their. T, a temperature change. City girls love their smart. S, a smell. City girls love their smartphones or precipitate forms. In this case, definitely a chemical reaction will occur. We'll have to determine how we know that in a minute. Okay, so I'm looking at my thermometer here, and I don't know if you can see in there real close, but I am getting about 19 degrees Celsius. So on my lab sheet, my initial temperature is 19 degrees Celsius. Take my temperature thermometer, and just for speedy's sake, I'm going to use a different one. Okay, so that I don't have to wait on each one. So this one is for my cooked liver. Wait about 20 seconds. It must be room temperature. I'm getting on this one right, I don't know if you can see that very well, right around 20 degrees Celsius. So I write 20 degrees Celsius on my initial temperature for the cooked one. And then get a new thermometer for this one. And then it must be room temperature. Wait about 20 seconds. Holy, I don't know if you can tell that, but right around 20 degrees Celsius. So they're all pretty close to each other. So on your Google Doc, those are our initial temperatures. 19, 20, and 20, probably around room temperature in this room. Okay, so now here's the thing. The instructions in this lab say we are going to add 10 milliliters of hydrogen peroxide. So, a little too much. I needed to be over a sink when I did this so I could pour it out. I'm pouring it in a cup beside you guys. Okay, so I have 10 milliliters of hydrogen peroxide. Now the first thing I'm going to do, I'm going to get my thermometer that I was using in the raw liver. Okay, and I'm going to leave the thermometer in there. It can handle this. I'm going to pour. Now while I pour this into, I also need to observe bubble activity. And on my chart, bubble activity 0 would be no bubbles, 5 would be the most bubbles that I've ever seen. So 0 to 5 on that scale. Here we go. This is raw liver. Oh, I'd say that's a lot of bubbles. Oh, going over. Now you can't see this at home, but I feel it. I feel heat down here. Heat is exciting. We call that an exothermic reaction. But just to do, the thing is I can observe that and say I feel it, but to be a real scientist I need some data, which is why this thermometer. It has shot up to 25 degrees Celsius and it's still going. It's going up to 26. It's still going. I'm going to give it 20 seconds or so. We're headed up to 27. Can't see because there's so many bubbles. Okay, the highest temperature, and it kind of stopped going up, was 27 degrees. So if I think about that, highest temperature in Celsius, 27 degrees Celsius. So what is that change in temperature? 27 minus 19. I'll let you guys figure that change in temperature out. Now our cooked enzymes, we're going to do the same thing. We need that thermometer in this one. Okay, we need 10 more milliliters of hydrogen peroxide. Whoa, that never happens. Your teacher got exactly 10 milliliters. Okay, here we go. What do you guys think? Hypothesis. A lot of bubbles? Not too many? You shall find out. Here we go. Okay, so remember this one started at 20 degrees Celsius. So in goes, well, that just was not too exciting. How much bubbles would you rank that? Not as much as the one before. Make sure you're ranking your bubbles. Okay, it did get hot, but not too much. I am sitting at 21 degrees Celsius. 21. 21 is where we're sticking. Okay, then it's going down. So on my sheet, cooked enzymes, 21 degrees Celsius. And I'll have to find the difference right there. Now, notice that when I am writing a temperature, that is under quantitative data. Quantitative data means data that you give a number to. It has a quantity. There's also qualitative data. You have to decide that raw enzymes, I don't know. Personally, I thought it was a lot of bubbles. So I'd probably go more on the 5 scale because it's made a huge mess on the table. Cooked enzymes, well, not too many. So you decide on that one. Okay, we have one more to go. So I stick my thermometer in this one. This one is the one that was kept overnight in acetic acid, which is vinegar. Whoa, I couldn't do it twice. I was hoping to get 10 milliliters again perfectly. Maybe it only happens once. Oh, not enough. Okay, we'll get it. Perfect. Okay, so this one we also started at 20. Here we go. Oh, Bubbles, where'd you go? I don't even feel warmth. Looking at my temperature, it hasn't moved. We're still sitting at 20. And we're still sitting at 20. We're still sitting at 20. 20 it is. Okay, so my acid and my enzymes at 0 degrees temperature change. You guys decide the bubbles. Now that you have all this data written, on page 2, it says that you need to graph it. Now these aren't going to be too hard to graph. What it needs you to do is make a bar graph. So, and you're going to want to submit your graphs in a picture form to me when you turn in this Google Doc. So if you remember, independent variable always goes on the y-axis. So we'll have 2 of them. One we labeled a change in temperature, and the other one we labeled a change in bubbles. So we have 2 graphs. We have down at the bottom, we need to, it's a bar graph, and remember we had raw liver as one, we had cooked liver as another, and we had liver kept in acid. So you will need to make down at the x-axis room for you to write your liver types. You also need on your bar graphs, you need a title. I would call the change in temperature a change in temp for liver. And then I'd actually fill in and make that bar graph. I would go make a scale to the side and do my temperature. Remember we started at 20 degrees, so maybe you could, it only went, the biggest one difference was about 8, so maybe I'd count by 10. And then I would make a bar graph go up for each one. So make sure you do that on your lab paper or when you submit your photos to me when you turn this in. Now you have some questions for the rest of the lab. Here are some things to think about in this lab. Enzymes are very specific to a substrate. So catalase only works with hydrogen peroxide. Now catalase can be reused over and over and over again, and it's an enzyme found in the liver. But it's only going to work on hydrogen peroxide, and it's going to break it down into water and oxygen. But it only does so if it's kept at its home base or homeostasis. And in this case, we messed with its home. we cooked it, which means we took that key, like if catalase is the key and it had a specific shape and it was supposed to fit in a lock and it's supposed to go like this and be a perfect fit, and we messed with the fit and it doesn't fit anymore. We did the same thing when we kept it in acid. Acid, you can imagine, definitely changed the shape of that key. They're no longer fitting. Another way you could think of them instead of a lock and a key is also like puzzle pieces. We changed the shapes of catalase, so it doesn't really match up with hydrogen peroxide anymore. That's called denaturing. Okay, if you have any questions, shoot me an email, message me, I will get it. But it's just some things to think about. And again, if you meet us at 3 o'clock today, I will be doing this lab live, and if you have questions, we can talk about it then. But you need to go ahead and answer the rest of those questions and make your graphs, submit them, and you're good. Hope you enjoyed your enzymes. Not much of a liver fan, so I think I'm gonna go clean this up and not eat liver tonight. Have a good rest of your day. Hope to see you at 3. Bye.